Okay, so in this section, we are going to be looking at the law of sines, and this is a formula that we use when we're working with triangles, except the triangles that we are now going to be looking at won't be right triangles, although there will be some problems where right triangles are mixed together with the type of triangle that you're seeing here. But in general, we're going to be starting off with triangles that are not right triangles. And what do you use when you're looking for sides and angles in that case? Because Pythagorean theorem doesn't apply because that only applies to right triangles. And also SOHCAHTOA and all of the trig formulas that we learned also don't apply because those are for right triangles. So when you are working on a general triangle, and by the way, this law of sines will work on right triangles as well. It works just in general. You can find sides and you can find angles. What we do have to try and recognize when we are first starting to work with law of sines is, how do I know when I can use law of sines? Okay, law of sines, you're going to see that, you'll have three sides, and this is just a typical convention that they use, where they use lowercase letters to name the sides, and then the corresponding angles, which will always be the angles across from them, will be the same letter of the alphabet, but capitalized. So this pair goes together, this pair goes together, the B pair goes together. This is the actual formula for law of sines, and you see that it is nothing more than fractions that are made up of, in every single one of these cases, a side and then the sine of the corresponding angle. In other words, the angle that's across from it. This is B and the sine of angle B. This is C and the sine of angle C. By the way, these fractions can be flipped over, so you can have the sine of the angle information at the top of all of them and all the sides at the bottom. If you flip one of the fractions over, all of them have to be flipped over. And I'll discuss with you when is it convenient to have the sine of the angle information at the top and when is it convenient to have the sides at the top. Just in general, I can tell you that whatever the unknown is, if it's sides that you're looking for, you don't know the sides should be at the top. If you don't know the angles and therefore that's what you're looking for, then the angle information should be at the top. So these can be written in reciprocal form. You're going to be seeing that we are going to be tackling a few specific cases here. So I want to give you a heads up on that. In order to use law of sines, this is the first thing that you have to know. You must have at least one complete pair. In other words, one angle and its corresponding side. Whether they use letters to name it or whether they use Greek symbols and other symbols on the side. You need one pair where you have the angle and the side across from it. Whether it be this pair, or this pair is irrelevant, but you need that as well as one other piece of information. And that third piece of information can either be a side or an angle, and you will work to complete that pair. So that's what you need to get it started. As you go and face these problems and you go to look for the answers, you're going to see that you're going to run up against two arrangements of information. If you are given two angles, whether it be side angle angle or angle side angle, and if you don't remember that from geometry, those are common abbreviations used when you have two angles and a non-included side. So let's say that in this particular type of picture, they give you this angle as a number and this angle as a number, but then instead of giving you the side in between it, if they do give you the side in between it, that's what's known as, and I'm talking about as numbers. They give you this angle as a number, this angle as a number, and this side as a number. That would be considered angle, side, angle. That's that abbreviation. If they give you two angles and then some side that's not included between the angles as values, then you're talking about this case, an arrangement of values that are angle, angle, and a non-included side. Okay, so for either one of these, you will be able to use law of sines for angle, side, angle, or angle, side, angle, angle. You can also use law of sines for two sides and a non-included angle. So let's say they gave you this as a value, this as a value. Those would be the two sides, and then an angle that is not in between these two sides. That's the angle that's between them. So if they give you two sides and then some angle that's not between them, such as A or B, that's called side angle angle. And that introduces what's called the ambiguous cases. Those ambiguous cases means that given side-side angle values, that your solution can either be what we call the zero solution, or it could be the one solution case, or it could be the two solution case. And what this means, 0, 1, and 2, it means that if given two sides and a non-included angle, there may be no possible way that the triangle can be drawn given the information that you're being given here. So when the triangle is impossible to draw, we call it the zero solution case. That only will happen in the side-side angle case. You don't need to worry about it happening when you're given this or this. So only when you're given one angle, and it has to be side-side non-included angle. Or it could turn out to be the one solution case where the triangle can be drawn one and only one way. Or it could end up being the two solution case when you're given this information, where the triangle can actually be drawn two different ways and you're going to have two different sets of solutions, full sets of solutions for two triangles. So this is why we call it the ambiguous case, because given this information, side-side angle, it could actually be one of the three, which you are not going to know until you get into the problem a little bit and it evolves in the middle of the problem. You'll be able to tell. Sometimes it happens very quickly, like in the no solution case, that you can tell that you're in the no solution case. And I'm going to, of course, give you an example of each one of these cases stemming from the ambiguous case side-side angle. Okay, so here I've just repeated it again. This is what we refer to as zero. The zero can also be referred to as the zero solution case. And this is the one solution case. So it can be referred to either way. This is just a description of what it means visually to have zero solutions when you're trying to solve these kind of triangles. What it means to have only one solution. You can only draw the triangle one way. And what it means to be in the two solution case. It means that you're going to actually have two different pictures and solving for all of the answers on each triangle. Okay, so here I just reiterate that again. I give you a little bit of information here at the bottom, just an important concept to remember if you want to go and have sort of a visual check on whether your solutions are correct or not. I mean, you won't know numerically if they're exactly correct, but if they are even possible. When you're done finding all the answers, this is called the triangle inequality theorem. Your answer should be such that the smallest angle is across from the shortest side. So small across from small, whatever the smallest angle is, that should be across from the smallest side. Whatever the largest angle is should be across from the largest or longest side. And the middle valued angle should be across from the middle valued side. Okay, so small across from small, big across from big, the biggest across from the biggest, and the medium across from the medium, if you want to break it down. Okay, let's get into the problems in my math lab, where they will be asking you definitions, some questions, and then like around problem 4, we get into the actual calculations using law of sines. This is very calculator oriented, so get your calculator ready. You will not be able to do these without your calculator. So for a triangle with sides A, B, and C, what does the law of sines state? They're just asking you to pick which one of these is correct. All of them are incorrect except one. Okay, so That's wrong because it has angle A matched up with side C. It should be angle A matched up with side A. This is wrong again for the same reason. Angle A has been matched up within the same fraction with side C. That is not the case. Here's angle A with side A, angle B with side B, angle C with side C. This is correct. And then if you check the rest of these out, they're not going to be right. This is A matched up with B, no good. This is A matched up with B, no good. This is B matched up with C, this fraction right here in the middle. If any of the fractions are set up incorrectly, the whole thing's incorrect. So those are all wrong except for that third choice. Moving on to question 2, state whether the following statement is true or false. The law of signs can be used to solve when there are just 3 sides are given. They're saying if they start you off with 3 sides, you can use the law of signs. That's false. I mentioned and made the comment that the way you know whether you can start this problem using law of signs is if you have an angle and a side across from it, and the side across from it. You must have at least that going for you in the problem, and then a third piece of information. So, can that be just 3 sides? No, that's false. Let's see, there's 2 choices that have false, because the law of signs means you have to have all 3 angles. You don't need all 3 angles. You need at least 1 angle and the side across from it. False because 2 angles and 1 side could be given. That's true. You could be given 2 angles. You certainly don't need all 3 though. Or you could be given 2 sides and just 1 angle. Yes, at least 1 angle has to be across from the side that corresponds to it. So it's false for that reason right there. Question 3, triangles for which 2 sides and an angle opposite to those sides is called side angle angle. Okay, and you can draw it if you want to, if you can't answer this question. Triangles for which 2 sides, let's mark 2 sides, and the angle opposite one of them. Okay, so either this angle or this angle. Let's mark this. Let's say these were our givens. Is this known as side-side angle? It definitely is, because if this angle would have been here, it would have been called side, angle, side. You trace over the marked pieces of information because they represent the given values that would start the problem off. So this is called side, side, angle. And let's see, referred to as side, side, angle. Triangles for which 2 sides are referred to as the ambiguous case. Yes, given these 3 pieces of information, that's what throws you into the ambiguous case, where you could either have 1 solution, you could actually have 0 solutions, or you could have 2 solutions. That's what we refer to as ambiguity. You don't know which one of those it's going to be, so it's called the ambiguous case. Okay, number 4, we actually get into the problems where we start looking at how to set up the fractions. So again, try to get your eyes on the pair that is complete, where you're given an angle and the corresponding side. That would be this pair in this case. You have the angle and the side across from it. So you're definitely going to make a fraction out of this pair, and then notice that there's another pair that they're prompting you into, where you have part of the pair, you have the angle, but you don't have the side across from it. So although the theorem has 3 fractions in it when they give it to you, you'll only be using 2 of these 3 fractions at a time. Okay, so we're going to, now notice that what's unknown here. We have 2 knowns and we have 2 pieces of information here. We know the angle, but we don't know the side. Since the sides are the things that are unknown, those should go in the numerator. Because remember, those fractions are flippable. So we're going to have side at the top and its corresponding angle, sine of that angle on the bottom. Then we're going to make one other fraction. That'll be this complete pair. We don't want any more unknowns. That's why we need that complete pair. We're doing sides at the top, sine of angles at the bottom. And then all you do is cross multiply. You're trying to isolate b, so you want to swing this right up into the numerator. You know what that is. That's called cross multiplying. You've been doing it way before you got to trig. So this is going to come right up here into the numerator. It'll be sitting right here and will no longer be on the bottom. And therefore the b is all by itself on the left side, all other numbers on the right. And then it's time to put it in your calculator. Make sure your calculator mode is in degrees and begin pressing this in. The numerator then divided by the denominator. Okay, so this is going to be 7 times sine of 45, close that up, divided by sine of 80, close that up, 5.026. I've been asked to, this happens to be a side, and for side B, it says round to 2 decimal places. So I'm going to call this 5.03. Okay, now you might want to put these things in the picture as you go along so that you realize you have options when you go to set up the next pair of fractions. Also a very easy answer to get here, and you could have gotten it first. You could have even gotten it before you even did this. So that order doesn't really matter. That's up to you. But you see that as you go to find side A, you're really going to need that angle A. So notice that 80 plus 45 is 125. And then you know that the 3 angles inside of a triangle always add up to 180. So subtract off the 125 that you already know about, and that would be 55 for angle A. You can go ahead and toss that right in there and continue with the problem. You have not solved this triangle until you have found each and every single unknown value. That's considered solving a triangle. So we still have to find side A. So therefore we're going to be using this pair, the A pair. We'll be using angle A and side A. My unknown is that side, so I'm going to put sides at the top, sine of angle A at the bottom. And then I'll do one other fraction. It's your choice. You can either use the 87 pair or you can use the 45, 5.03 that we found. I'm going to use the 80. So I'm going to do sides at the top, just like I did sides at the top here. You have to keep that consistent or that will make the answer come out wrong. And I'm going to do sine of 80 on the bottom. Okay, again, you would like to isolate A. So all that's going to take is swinging sine of 55 right across that equal sign, known as cross multiplication. Cross multiplication, what you're really doing is swinging the denominator right up into the numerator. Okay, so now you have everything over on the right side, and again, go to your calculator. So it's 7 times sine of 55, close that up, divided by sine of 80. Anything that's on the bottom is a divisor. And that gives you 5.82. Let me check that real quick. I did sine of 55 times 7, then I took that answer and divided by sine of 80, so 5.82, and this is A. Rounded to 2 decimal places. And then A was 55. Okay, that completes number 4. Moving on to number 5 on the next page. Okay, so in this one, let's see, what complete pair of information do we have? It doesn't appear that we have anything where we have the side and the angle across from it, although we really do, because if you notice, if you do find angle A first, then you actually have one complete pair right here. You'll have angle A and the 14, so that's easy enough to do. We'll just go 37 plus 56, which is 293. Whoops, pressed that in wrong. 37 plus 56, which is 93. So I'll actually put that here just so I don't leave you wondering where it came from. Oh, I think that's pretty simple for most of you. So we have 93 so far, and if we subtract that 93 from 180, we get the final remaining angle. So 180 minus 93 is 87, and that'll be angle A. So now we do have a complete pair. So one of our fractions is going to be made up of the 14 and the sine of 87, and then you have a choice. You're left with either being, should I find C or should I find A? Find the smaller angle first. Find the side associated with the smaller angle first. That seems to be a source of confusion for students, so let me just recommend that to you. We're going to go after this pair. We're going to complete this pair right here. So again, see, notice that it is a side that is unknown, so I'm going to put the side at the top. Now, it doesn't matter which of the two fractions you write first. You can write this one first, or you can write this one first. It's irrelevant. Okay, so side C goes with this angle 37, but we are doing the sine of these angles, which is why it's called law of sines. We need one other fraction. That would be this complete pair so that we don't introduce any more unknowns. Sides at the top, sine of the angle at the bottom. Okay, then we're going to isolate the C. And by putting the unknown at the top, you will get rid of one of the steps that you'd be doing an extra step if it was down at the bottom. So we're going to swing this right up here. We are cross multiplying. You don't have to show that little symbol that I'm drawing. So sine of 37 is now up in the numerator, no longer in the denominator, and we're ready to put it in the calculator. So it's just 14 times sine of 37, get that numerator, and then don't forget to divide by whatever is in the denominator, which is sine of 87, because a lot of students forget that, and then they just have half an answer. So the final answer is here. We went 14 times sine of 37, then we divided by the sine of 87, and we got 8 point. Let's see what they want us to round to. 8.44. Yep, they want 2 decimal places again, and we have just found C. Approximately 8.44. We already know what A is because we found that to begin with, and we have only one other piece of information to find, and that's going to be B. So let's set up another pair of fractions. I'm going to go with the 87 and the 14 again. Again, I'm looking for a side. So I'm going to do that side over the angle that corresponds to that side, which is the 56-degree angle directly across from it, and then I'm going to use one other fraction of my choosing, which will be the 87 and the 14. Sides at the top, sine of 87 at the bottom. Cross multiply the sine of 56 right up alongside this other numerator, this numerator of 14, so that it is no longer on the left side with the B, but rather the B is alone. Those squiggly marks just means you're approximating. So I'm going to put in the calculator now. 14 times sine of 56 divided by sine of 87, which is 11.62. Okay, so now we are in, let's see, number 6. I think I'm going to leave number 6 alone because this is just more of what I did in problems 4 and 5. You have 2 angles and you have a side. Okay, so I'm going to skip to, I guess I'll skip to number 7. Okay, number 7, the only difference, now that you've gotten down to 6 and 7, we haven't gotten to any of the ones where it's the ambiguous case yet. That's when you're only given one angle to start with. So you don't know whether you're in the 1 solution case, the 0 solution case, or the 2 solution case. And we haven't even gotten to that. The only thing that's changing right now as I go into 6 and 7 is that you're drawing it yourself. So I'm going to go ahead and jump on to number 7. Okay, draw the triangle any way you like because the answers are not going to come out different just because you draw it. One person draws it differently than the other. Label however you want. I'm going to start with an A here and go around this way. Okay, and so then this would be side A across from angle A, side B across from angle B, and side C across from angle C. Go ahead and put the numbers in that they've given you. So angle A is 50. Angle B is 50. And by the way, this is an isosceles triangle. Whenever 2 of the angles are equal, that means that the sides across from them, this side and this side, are also equal. We don't know what they are, but we do know that when we find one of them, we've actually found both of them. So that's going to kind of help us to cut down on our work. So if you don't remember the isosceles triangle theorem from geometry, just a little reminder of that. So this is if 2 angles are congruent, equal, then the sides opposite those angles are also congruent. Okay, this having 2 angles right away allows you, just as in the last 2 problems that I've done, allows you to find that third and missing angle. So we have 100 so far, so we'll just go 180 minus the 100 that we already have. That gives us 80, and we know that this is 80. Okay, then moving on from there. So we have found, let's see. And I actually think that I didn't put the 2 on there yet. That's I wanted to see if there's any other information that I didn't put. So the C is 2. I have my 50s. I have one answer already, which was this. And now I just have to find A and B. So as I look at this, I see that I have a complete pair right here after finding that 80. And I'm going to go ahead and, it doesn't matter which one you find, because when you find one, you're really going to be finding the other one as well. I'll go after A. So I'll go A, putting the side at the top, since I'm looking for sides, over sine of 50 is equal to, and then I'll put another pair here, which would be the pair where I have a side of 2 and a sine of 80. I'll go ahead and isolate that one unknown that I have by swinging this sine of 50 right up into the numerator. So again, the only thing that's different here is that you had to draw it yourself. And just to stop yourself from doing twice as much work or doing the same thing twice, it's good to know about the isosceles triangle theorem so you don't go looking for B as well. Okay, so pressing this in the calculator, we have 2 times sine of 50 divided by sine of 80. And that is 1.55. Let's see what they want us to round to here, but probably the same deal. Probably 2 decimal places. Let me move my calculator so I can check that out. Yes, rounding to 2 decimal places, so 1.56 actually. And then B would be the same. Okay, so not as much work for that one, only because of the isosceles triangle theorem. Okay, so here we finally get to a situation where we only have one angle. And that one angle is 30. Now, because you only have one angle, and let's make sure that this is the side-side angle case. You can draw a little picture for yourself and label it A, B, and C. You don't have to label it the same way I do, but that's how I do it. Make sure you understand that that's side A because it's across from angle A. This is side B because it's across from angle B, and this is side C. So as we go to put the numbers on there, we have a 2 right here. We have a 1 for this side, and we have 30 degrees right in here. So yes, this is definitely side angle, side, and a non-included angle. If the angle was here, we would not be in the ambiguous case. Okay, so it is unclear whether you are going to have one solution, 2 solutions, or no solutions. And that's going to reveal itself as we begin to work the problem. Okay, so let's start to set up the fractions. All right, so one pair that I'm definitely going to use is this A pair. You have the angle, you have the side. So I'm going to go with, let's see, and what are we looking for? I could also be prompted, I'm being prompted into using the B pair because you actually have part of that pair. So I'm going to use the B pair as well. In these pairs, it is the angle that's missing. So I'm going to put angles on the top. I'm going to go sine of angle B, which is across from side B. And then I'm going to go sine of angle A. And then side A, which is across from it, which is 2. Okay, you are isolating for angle B. You're cross multiplying by 1, which doesn't change anything. So it's sine of angle B. Excuse me. Drink something. Okay, so we have a sine of 30 on the top divided by 2. Go ahead and put that in the calculator. And that gives you 0.25. And then if you recall from chapter 7, that when you're looking for an angle, only when you're looking for an angle, you need to do the inverse. So to rewrite this, if you recall from chapter 7 into an inverse statement, all you do is switch the angle and the number. its inverse of 0.25 is equal to the angle. Okay, now we're going to put this, we want this to be in degrees. It's already in degree mode. I'm going to clear this out, and I'm going to do second inverse sine. I'm going to put in the 0.25, and I get 14.4775. Let's see what they want us to round it to. All right. Let's see what it says here. Total answer below. Rounded to 2 decimal places. Okay, so 14.48. Okay, now right here is where you're going to check whether or not, now you may be tempted to go on with this problem and say, oh, I only have one set of solutions. But notice that the answers here are that there's only a single triangle produced. That's the one solution case. And then they give you room to give all the answers to that one triangle. But another choice is that there are 2 triangles that are produced. Well, being able to check whether it's this situation. Now, if it was no triangle produced, you know what would have happened? The minute that you would have gone to press in these calculations, you would have gotten an error in your calculator. That's how you know when you're in the no triangles are produced case, because the numbers that they gave you throw you into an undefined situation. So then that would be the answer. Your calculator will alert you to the fact that you're in an undefined situation, which means no triangles are produced, by saying error, quit. It'll quit on you. But you have to select, is it this case or this case? And right now is where it happens. Notice that I have only found one answer so far. So if there is 2 different ways to draw this triangle, you figure it out right when you calculate the very first angle. You ask yourself exactly this. What is 180? You will always do this as soon as you find your first angle, minus the angle that you've just found. And in this case, that would be 180 minus 14.48, 165.52. You're going to ask, is this angle a possibility for angle B? Because what you're doing is you're questioning whether or not angle B could have been something else. Because if it can be something else, that means that the triangle can be drawn 2 different ways. And this is always how you're going to approach that question. As soon as you find your very first angle, which will be it'll be the first answer you find, you're going to subtract it from 180. This will be what you do first. And then you're going to ask yourself, is this possible? Could you possibly put this angle that you just got, whatever the answer happens to be, could you put that right here? And the answer to that is no, because if you did put that 165 degree angle right here, I know there's a 0.52, but let's just round it off for conversation's sake. If you were to put 165 right there, plus the 30 that you already have there, that throws you into 195 degrees, and that's not possible. You can't go over 180, so therefore this is not a possibility. That is not possible. And this is why, because the 30-degree angle plus the 165 that you're contemplating putting here rather than the 14 that you thought it should be is equal to 195, and that's too big. Let me try and move this over because I'm not able to write the whole thing. Okay, it's not possible because of what I'm writing here. The 30 degrees plus the 165 is equal to 195 and 0.52 degrees. And that's just not possible to have that many degrees inside of a triangle. It's too much. Therefore, you're going to take this 14.48 and you're going to stick with that. So that means this can be nothing more than, can't be anything other than 14.48. You temporarily contemplated whether it could be some other angle, and that some other angle is always calculated by going 180 minus what you just found, and then you ask yourself, will this angle throw you over the 180 limit? You can see that it did, and therefore we have to stick to our original option, 14.48 degrees. Okay, so that means that we have B, we have angle B, we have A, we have angle A, and all that remains for us to find is angle C at the top. And since we already have these two angles, that's pretty easy. Okay, so we know that right here from all these questions that we asked upon finding our very first answer, that this triangle can be drawn one and only one way. That means you are in the one solution case. Only one possible triangle can be drawn. So the answer is this right here. And then you have to give the answers. Okay, so B was, we confirmed that could only be 14.48. And angle C we haven't found. Side C, let's see, oh, we haven't found side C yet either. Okay, but C, angle C we can find very easily. Okay, I'm going to continue that right here. Don't have much room here, but I can go after side C. So this was one. This is the second thing that I'm finding. I'm finding, let's see, angle C, which is 180 minus, we've got to take off the 30 that was in this corner, and also take off the, I mean, you could add those two together and then subtract them both at the same time. You're going to get the same answer either way. Let's see, that would be, and that would be 135.52. For angle C. And then the last thing we have to find is C. I've run out of room, so I'm going to move that to another page and finish this problem for you. Okay, so let's see. If I was going to find side C, I would definitely need to use the angle across from it, the 135.52. So I will use this pair right here. Looking for C, the angle that goes with it is 135.52. So this is number 8, the very last portion. And then I can pick one other pair from this triangle. I'm going to go ahead and use the 30 and the 2. So 2 is the side, 30 is the angle. Okay, and then let's see, let me see if I can focus this a little bit. There we go. Okay, and then you want to isolate the one unknown that exists in this proportion by swinging this right up here. So this is not there anymore. You just see, and you're going to go put all of that in your calculator once you get all the numbers on one side. So putting all of that on one side, we have 2 times sine of 135.52. That's top, divided by sine of 30 on the bottom. And our answer is 2.80 for that side C. And that completes number 8. A lot of work for that one. Okay, moving on to number 9. Alrighty, let's see. So in number 9, it says 2 sides and an angle. One angle, so you're only given 2 sides and an angle. Determine whether the given information results in 1 triangle, 2 triangles, or no triangle. Now these are a lot of work and there's no room here, so I'm going to do this on my own paper. Problem number 9. They've given you B is equal to 8, C is equal to 10, and angle B is equal to 30. Okay, so let's do a drawing. Like we've done in a couple of the problems thus far. Okay, I'll put my drawing right here. I'm going to leave some room over here just in case there's 2 different ways to draw it. I'm just going to imagine that it can be drawn like this. This would be side A, which we don't have. This would be side C, which we do have. Angle B we know is 30 degrees. And B, side B is equal to 8. Okay, so here we go. We're definitely going to use this pair in the law of sides because it is complete with an angle and a side. So I'm going to go, and let's see, what other pair would I be using? I'm prompted into this pair because you have part of it. You have the side but not the angle. So I'm going to go after this, angle C. So since angles are what is unknown, I'm going to put angles at the top. So I'm going to go sine of angle C, and I'm going to put the side that's across from it as the denominator. Okay, then I'm going to use my complete pair, sine of 30, and the side that's across from it. I'm then going to cross multiply with this 10, bringing it from the denominator into the numerator. So it's not there anymore, and now I have sine of angle C, and you can put the little angle symbol if you want to, or not. And let me get this calculated. This would be sine of 30 times 10 in the numerator divided by 8. That gives me 0.625. But with these, when you're looking for an angle, you have to go a step further because you have to rewrite this as an inverse whenever you're looking for an angle. So now it's inverse of 0.625 is equal to angle C. And you'll be finished when you put that in there. So it's second inverse, and you can just put the answer in there by pasting it. And you get 38.68 degrees in this problem. Type of decimal rounded to 2 decimal places, so 38.68 for, let's see, what did we just find? Angle C. Okay, but now let's review what I did in the last problem. Anytime you have 2 sides, you were given 8 and 10. Here's your 2 sides. And then instead of being given the angle between the sides, which would have made it angle side, which would have made it side, angle, side, you were given an angle that's not in between the 2 sides. That is known as the side-side angle case. This right away implies that as far as solving triangles, you are in the ambiguous case. which means it is possible that you can only draw this triangle one way with just a 38.68, but it's also possible that angle C can be something other than 38.68. So the way you ask yourself, are there any other possible ways for drawing this triangle? And let me show more of this page. Is the minute that you find this 38, you're going to entertain, is there another possibility for angle C? And you're going to consider that possibility by first going 180 minus the 38.68. Still not seeing enough of the page. Well, let's try that. Okay, so I'm going to go 180 minus 38.68, and that is 141.32. And then what I'm going to ask myself is, once you do the subtraction from 180, ask whether this angle, will it work for angle C? Remember, the very first thing that you found was angle C. But can angle C, that very first angle that you found at the very first answer, could it be something else? So let's imagine if instead of putting the 38.68 up where angle C is, let's imagine putting the 141.32. Okay, so if we did 141.32, and there was a 30 here, what's 141 plus 30-ish? 141 plus 30 would bring you into 171 degrees. You are well under the 180 degree limit, and therefore this triangle can also be drawn. This triangle can also be drawn using the 141.32 for angle C. So I'm going to write that down here. Since the 30 that is there plus the 141.32, since that does not throw you over, it is not greater than 180. That means you still have room for a third angle. Even if you put the 141 right there, that plus that is only up to 171. That means you have still some degrees to devote to angle A. So what this means is that you are in the two solution case. This is the hardest of the cases because it's the most work. But I think what students get the most messed up about is, hey, how do I check whether or not I can draw that triangle a separate way? And you're going to have to memorize the steps that you go through. First, you just subtract the answer that you just got. You'll be looking for an angle through law of sines. You'll find it. And that very first angle, you're going to subtract it from 180 and then ask yourself, does it throw you over the 180 degree limit for triangle, for the angles inside of a triangle? It didn't this time. In the last problem, it did. I got like 195, too big. You have to have enough room, even after you add the two angles, the one that was given in the original problem plus the one that you're entertaining, whether it can be a possibility, you have to have, it can't be bigger than 180. So, since it wasn't, that means that we can redraw this triangle a second way, and that would be this. You're going to leave all the given information as is. The only thing that you're going to change is what you found. Okay, so all these things were given. The only thing that we have found ourselves is angle C. And this very first one that we found right here is a possibility. This is one possibility. And this 141 is a second possibility. Okay, so in one of the triangles, we're going to put the 38.68. And we're going to continue finding all the answers until we're done finding all the answers. And in the other triangle, we're going to use our other possibility for angle C, which is 141.32. Okay, so now continue working these two triangles now that you have them both drawn, and you should definitely draw both of them. I'm going to expect you to show me both triangles drawn out, showing me where the first solution is that you found, and then the alternative possibility, which you are also going to find a set of solutions for, because this angle that you found up in the position where C is, it alters all of the remaining answers. So you'll have one set of answers that goes with 38.68 as angle C, and another set of answers that goes with a 141.32 for angle C. Okay, so I'm going to continue with this first triangle. Get all the answers, and then I'm going to work on the second triangle. Yes, these are a lot of work, but that's what happens when you double the amount of triangles you have. So I'm going to find this remaining angle first. I have two angles here, which let's see, the sum of that 38.68 plus the 30 down in the bottom corner, that's 68.68. So when I go to find angle A, that's just going to be 180 minus 68.68. And that's 111.32. Okay, then the only answer that's left to be found in this first triangle is A. So you're going to do the 111.32 with the A. That'll be one of our fractions as we return to law of sines. And then you can either use this pair right here, the C pair, or you can use the 30 and the 8. I'm going to use the 30 and the 8. Okay, so I need to find side A. Let me just write this and then I'll show you the fraction. I want you to be looking at the picture. I'm going to use A on top of the fraction, sine of 111.32 on the bottom of the fraction. And then I need one other fraction. I'm going to go with this simple pair, the 30 and the 8. So the side at the top, sine of 30 at the bottom. Okay, then you're isolating for the one unknown that you have, which is side A, by swinging all numbers to the opposite side. Okay, so now I put this in the calculator. And that's going to be 8 times sine of 111.32 divided by sine of 30. And that gives me 14.91 for A. And that finishes that answer. Okay, then go in and get all the answers for the other triangle. So moving on to this other picture, I'm going to go in the same order. I have two angles and I need that third one. So all I'm going to do is go 180 minus these two added together, which is 171.32, in order to find angle A. So 180 minus 171.32, that's 8.68. Okay, then all I have left to find at that point is side A. Just like in the other problem, I found the the third angle that was missing, and then the side across from it. So I'm going to go into law of sines again. Side A across from the 8.68 degree angle, taking the sine of it. I'm going to set up one other fraction. Then I'm going to use this simple pair without the decimals. Not that you can't use the other one, that's up to you. So I'm going to go the side and sine of 30 on the bottom. Okay, so cross multiplying, in other words, swinging this sine of 8.68 degrees right up into the numerator so that no numbers are on the same side with the A, and then just calculate this quotient here. So 8 times sine of 8.68, close it up, divide by that denominator, which is sine of 30, and you get 2.41. Okay, so different answers on each of these problems. The answers that you found, because angle C is different in each one. So now just take all these answers and go back to the sheet with the answers. Okay, so it's this choice right here that there are two triangles that are produced. And let's see, how do they want these answers? Okay, two triangles are produced where the triangles with the smaller angle C. So be careful when you go to give these answers that you're paying attention to their prompts for each question. So the smaller angle C was the one with 38 degrees. .68 degrees. And in that case, angle A was 111.32. I guess you don't have to put the degree symbols, it just got cut off here. And then for the other triangle, that I guess they didn't ask you all of the answers here. They asked you for the one angle, and then they asked you just for angle A. That's all they asked you. So just answer whatever they give you. So now, see how these answers that you put up here have little subscripts of 1? That means that all of these belong to the same triangle. Notice that these have little subscripts of 2, which means they belong to the other triangle. So if this one was about the smaller angle C, then this must be the triangle with the bigger angle C, which, as you can see, was this one right here, the one with the 141. They're asking what's angle A, 8.68. And they're also asking what was side A. Okay, that concludes numbers 1 through 9, and in the next video I'll be doing 10 through, I believe there are, let's see, some word problems up through about 14. I'll do numbers 10 through 14 in the next video.